Exercise 310, angles of elevation and depression. So the angle of elevation is the angle looking up. So just think, if you are there and you look like that normally, that's your eye, and you look out across when you're walking, and if you see something up here that you want to look at, like the sun, you will turn your head and look up. So that's the angle of elevation. So the angle of elevation is the angle looking up. It's always measured from the horizontal. Okay, the angle of depression is the angle looking down. So once again, if you're a person and you normally look straight ahead, and let's say you see something down here and you want to look down at that, then you need to tilt your head down that much, because you normally look like straight ahead at the horizontal. If you see an object down here, the angle of depression is how far you have to move your head down or your eyes down to see that object down there. So just think, you're always looking straight ahead. Elevation, you're looking up from the horizontal. Angle of depression, you're looking down. Okay? So in this diagram up here, that's the angle of elevation. This down here is the angle of depression. So first, question number 2 from the exercise. From his ship, Captain Sven observes a lighthouse on top of a 40-meter cliff. So, you know, you've got your ocean, you've got your boat, your ship here. Here is your cliff, and you've got a lighthouse up here. Okay? So here is your ship, and you've got the lighthouse up there on top of the cliff. Okay, so basically looking up like this. Okay, so from the ship here, and that's your lighthouse. The captain observes a lighthouse on top of a 40-meter cliff. Where do I put the 40? Yeah, the cliff is 40 meters high. The angle of elevation is 16 degrees 41 minutes. So from the horizontal looking up, this angle here is 16 degrees 41 minutes. So I'm going to draw a nice triangle. We've got 16 degrees 41 minutes. Girls, you have to assume horizontal and vertical, that the cliff goes vertically upwards. Okay? And that's your diagram. That's your right angle triangle that you will use. How far to the nearest meter is the ship from the base of the cliff? Do we want this distance here or the hypotenuse distance? How far to the nearest meter is the ship from the base of the cliff? Now here's the cliff. Where's the base? The base is the bottom of the cliff. You want this distance along the bottom. How far is the ship from the base of the cliff? Not from the top of not to the lighthouse, from the base of the cliff. Remember, this is water down here. That's your big cliff with your lighthouse on top. We've got opposite and we've got adjacent, or we're trying to find adjacent. There's nothing about the hypotenuse that we need. So it's O and A. So tan theta is opposite over adjacent. Tan of 16 degrees 41 minutes is 40 over D. My pronumeral is on the denominator, so I do that diagonal swap with there, and you can work this out. Remember, this is going to be a distance, not degrees and minutes. This is a distance. The question is in meters. This answer will be in meters. So to the nearest meter, it's 133 meters to the nearest meter. Okay? Okay. Well, Liam's seat is 20 meters from the stage. So I'm going to put his seat, it's higher than the stage, and the stage is down here. Okay, so his seat's up there, the stage is down here. I'm going to draw a triangle now, just a dotted triangle there for now. So his seat is 20 meters from the stage. That would be the horizontal distance from the stage, and his seat is 5 meters above the stage, but they're asking for the angle of depression to the stage. So if this happens, just draw the rest of the rectangle up here so that you will get an angle of depression, because we're not asking what's the angle of elevation from the stage up to the seat. We're not asking that. If we were asking what's the angle of elevation from the stage up to the seat, we'd be finding this angle down here. But if we want the angle of depression to the stage, it's from him to the stage. So complete it as a rectangle. And the angle of depression is the angle looking down. How far is he looking down? At what angle is he looking down to the stage? Remembering it's a rectangle, if that's 5, this is 5. And if that's 20, this is 20. So I'm going to be using the top solid rectangle, triangle. So again, what are we using? Sine, cos, or tan. I've got opposite and adjacent. So I've got tan. So tan theta is opposite over adjacent. Tan theta is 5 over 20. Theta is, now you can simplify that to a quarter if you want now, or you can just go theta is tan to the minus 1 of 5 on 20. That's what you'll enter in your calculator. Because you want the angle of depression to the nearest degree, you don't have to change your angle to DMS, okay? You can just keep it in degrees, whatever you get, and then round it to the nearest degree. On your calculator, you get 14.036. Because you need to round to the nearest degree, don't go and change it to degrees and minutes. Just keep it like that and just treat it as a normal decimal number, and to the nearest degree, that would be 14 degrees. Amiens stands on the roof, I'm assuming he's here, of his apartment block and sees a bird on the roof of a neighbouring office at an angle of elevation of 14 degrees. So he's here, he looks up, and this bird is at an angle of elevation of 14 degrees. And at the same time, he sees a dog, so he then looks down, a dog at the bottom of that same office building at an angle of depression of 33 degrees. And if the two buildings are 280 metres apart, find how far the bird is from Amiens. Now, just looking at the bird one first. Now we know that the bird's up here and Amiens down there, and the angle of elevation is 14 degrees. And we know that the distance between the two buildings is 280. So if this is 280, so is that distance there. So this is 280 metres. How far is the bird from Amiens? It's actually this straight line distance. Okay? Okay, so we want the hypotenuse. I'm going to call this D. Okay, do you want to do that? So we've got, in reference to this 14-degree angle, we've got the adjacent and we've got the hypotenuse. So this distance here is 280 because, look, that's 280 there. This is 280 here. Okay, so we've got tan theta. No, it's not tan, it's cos. Cos theta, because we've got adjacent and hypotenuse. Cos theta is adjacent over hypotenuse. Cos of 14 degrees is 280 over D. The D is on the denominator, so I do my swap diagonally. 280 over cos 14 degrees, and I can just put the answer over there. 288.57 or 289 to the nearest metre. Now, I think in part B, when we work out the distance from the dog, I would not be using this rounded answer. I'd be using the 288.57 a bit later when we add it to our part B answer. Okay, now for part B, how far is the bird from the dog? How far is the bird from the dog? We can't work that out using the one triangle. We're going to have to work with this lower right angle triangle. We're only working with right angle triangles at the moment. So we've got a right angle up there and a right angle down there. So we're going to draw that bottom triangle for part B, where the angle of depression is 33 degrees. So that's 33. This distance across here is 280, which means this distance is also 280. So this distance here is 280, right angle. I'll call this X or H, doesn't matter what I call it. Okay, so we need to work out that distance. Actually, we're not even going to use that answer from part A at all. Just realise that. So how far is the bird from the dog? So in part A, we've actually worked out this answer up here. It's got nothing to do with our answer for part B. We're going to have to work with two triangles in part B. Okay, let's keep going. So we're going to work out this distance here, and we're going to have to work out this one here, this x here. We're going to have to work out that y as well. Because there's the bird, there's the dog. Okay? So you're going to have to do another 2 calculations. All right, working with this bottom triangle first. What are we using? Sine, cos, or tan? We've got opposite, we've got adjacent. So we're going to use tan. Tan, can I just set it straight out? Tan 33 is opposite. No, it's all right. Let's put it here. Tan theta is opposite over adjacent. Tan 33 is x over 280. How do we do x? Times 280 times tan 33. You can work that out. You're then going to have to use that top triangle again and work out this distance y. Here for x is 181.834. Please don't round it off. You need to find y in this other triangle. Again, that's opposite, that's adjacent. It's going to be tan again. So we've got tan of 14 degrees is y over 280. Y is 280 times tan 14 degrees. And answer. What do you get? Anyone? And y distance, we get 251.64 approximately. To the nearest metre, it's 252 metres. Okay? So please don't round off when you're working out those first few. If you want your answer to the nearest metre, I'd be carrying at least a minimum of 2 decimal places. I've put 3 there. Okay? Then get your answer and then round it. Okay? Do not round to the nearest metre here and there, because you may get it right, you may get it wrong. With this problem, question 12, it's a very typical similarity problem that you would do as well. So, remember shadows are caused by the sun, okay? So I'm going to draw the sun up here, and basically the sun's rays will be shining down, okay? Now it says a 2.5 metre totem pole casts a shadow of 2 metres, and it says what is the length of the shadow of a 6.4 metre tree? So 6.4 metre tree is obviously taller than the 2.5 metre totem pole. So here's my sun. I'm going to put my tree roughly here, and it's 6.4 metres high. That's my tree. And then my totem pole, I'm going to draw further along here, and the totem pole is 2.5 metres. The sun is shining. Here is a tree. It's 6.4 metres high. Here is a totem pole 2.5 metres high. Okay, now they will both cast shadows. I mean, I can draw the two triangles separately, but I don't want to. I mean, I can draw them separately in a minute. But there's the tree. This is the shadow of the tree, right? And this is the shadow here of the totem pole. Now I'm going to have to do that again. So the shadow of the totem pole is 2 metres, but this here is the shadow of the tree. Okay? The reason we draw it in like one triangle within the other is that it needs to be at the same time of day with the same angle from the sun. Okay? All right, so the first question is, what is the length of the shadow of the tree? Okay. Now, part A, this is the sort of question we did in exercise 302. I've got a right angle triangle here, and I've got a right angle triangle there. Now, do you think that this angle down here is the same for both triangles? Yes or no? Yes, it is. One triangle. There's the big triangle. This angle down here belongs to both triangles. What I'm going to do is draw the two triangles separately. Here's the big triangle for the tree. 6.4 meters. This is the shadow of the tree. Pretend the sun's up here. Okay, here is the smaller triangle. So, with the totem pole that's 2.5 meters high, it's got a shadow of 2 meters. So, girls, if the sun's up here, you know, and this is the pole, the shadow goes behind the pole. Just think if the sun's behind you, the shadow's in front of you. Okay? So this is the shadow of the pole on the ground. The pole is 2.5 meters high. Its shadow is 2 meters. Shadows are measured on the ground. You see shadows on the ground. Shadows are not mid-air. Okay? Here's the tree. We don't know the length of its shadow. I'll call that X. Okay? So, because it's the same time of day, we have to assume the tree is vertical to the ground. We have to assume the pole is vertical to the ground, but we draw them within the same triangle. So this angle here is the same. In other words, the two triangles are similar. We've got similar triangles. Now, do you remember how we set up and worked out the missing side in this triangle? We go X, what side does X match with? Anyone? X over 2 equals, we started this in 302. X over 2 equals 6.4 over 2.5. Look, remember there are two methods to find X. Scale factors gets complicated and long. I would just set up the ratio, method 2. X's partner is 2 and 6.4's partner is 2.5. So, always do the unknown first. X over 2 equals 6.4 over 2.5. If I want to make X the subject, how do I do that? If I want to get X on its own. At the moment, it's X divided by 2. So, instead of opposite of dividing by 2 is timesing by 2. So, therefore, X is 6.4 divided by 2.5 times 2. 5.12 meters. So that's the shadow cast by the tree. That seems pretty good, okay? And then you just need the angle of elevation of the sun. Girls, I would use, look, this X distance is a rounded distance. I wouldn't use the big triangle. I would use the small triangle. The angle of elevation, where do you think it is? Angle of elevation, looking up from the horizontal. I've marked it with a dot. That's the angle of elevation with a dot. So that's my theta. I'm going to use the second triangle, not the first, because there are no rounded measurements in the second triangle. Okay? So if I want my angle of elevation, it's that one there, looking up from the horizontal, sine, cos, or tan. Opposite, adjacent. Tan theta is opposite over adjacent. Tan theta is 2.5 over 2. Theta is tan to the minus 1 of 2.5 over 2, which is, and they want it to the nearest minute, so you're going to have to do DMS, change your calculator display of degrees. When you get your answer, you need to make it into degrees and minutes. What do we get? 20 minutes, 24 seconds, roughly. 51 degrees, 20 minutes or 21 minutes? 20 minutes. Okay. 15, a point. Stephanie is at a point S, rowing towards point perpendicular. So rowing this way, which is on a 230 metre vertical cliff. Okay, this is question 15 in the angles of elevation and depression, exercise 310. So Stephanie is at point S, rowing towards point perpendicular, here P, which is and here we've got a 230 metre vertical high cliff. She measures the angle of elevation, so from S she looks up to C, and the angle of elevation from S to C is 18 degrees. Okay, so she's basically rowing in this boat towards P. So initially she looks up, the angle of elevation to C is 18 degrees. She then keeps rowing forward, and it takes 3 minutes to get from there to there, so that takes 3 minutes. And then she's here, and then she looks up again, and the angle of elevation to the cliff is 22 degrees. And the question is, how far to the nearest meter did she row during this time? So this took 3 minutes to get from there to there. I don't need to put 3 meters there, but we need to find that distance there. So remember, we're doing only right angle triangles. So here's the large triangle, and I'm going to indicate that by putting C, P, and S over here. So in the large triangle, I know that this is 230 meters, and that this angle, so CPS, that this angle down here is 18 degrees. Okay? Now, I've also got this smaller triangle, so I'm going to call this S, I'm going to call this T, this point T. So here's my smaller triangle. I've got CPT. This height is still the same, 230 meters. And this distance here, we don't know, but we know that this angle here is 22 degrees. So I've got these two triangles here. And the question is, how far did Stephanie row from there to there? Now, I can't work out from there to there because it's not a right angle triangle. But what I can work out, if I use the big triangle, I can work out from P to S, which is this distance here. I'm going to call that X. And in this small triangle here, CPT, I can work out this distance, and I'm going to call that Y. So again, here's the big triangle, CPS. This distance along the bottom is X. In this small triangle, CPT, this distance along the bottom, I'm going to call Y. Okay, so I'm going to work out X and Y in both those triangles. So I've got an opposite here, and I've got adjacent there. So I'm going to use tan. So tan of theta is opposite over adjacent. Tan of 18 degrees, opposite is 230 over X. I'm trying to work out what X is. It's on the denominator. I'll swap it diagonally. So X is 230 over tan of 18 degrees. And we can just work that out on our calculator. 30 divided by tan of 18 degrees is 707.867. Now, using the smaller triangle, I'm trying to work out this length Y. So again, we've got the opposite, we've got the adjacent. So tan of 22 degrees. So again, we're using tan theta is opposite over adjacent. So I've got tan of 22 degrees is opposite is 230, adjacent is Y. So Y equals 230 over tan of 22 degrees. We can work out Y. Y is 569.2699. So I'm going to draw this all up again. This is actually what I've got. So I've got, remember, I've got the big triangle and the smaller one. And this was 22 degrees, and that was 18 degrees, and this was 230. And we worked out that this was called Y, and this was 569.2699. And this big thing, all that distance there, was called X, and that was 707.867, etc. And what I needed to work out was this distance D. So you can see quite clearly there that D is going to be this distance, which is X. So X minus Y, so which is 707.867 minus 569.2699. You know, you might want to put one of those numbers in memory on your calculator, and just calculating that now, 138.59. So the question is, how far to the nearest meter did Stephanie row? And it was 139 meters to the nearest meter. So this distance here is 139 meters to the nearest meter. Please don't round off till the end. You don't want to round this off, because if you did, you would have had 569 and 708. And when you subtracted, you may not have got that exact answer. Sometimes you will, sometimes you won't, but please don't round off till the end, okay? So the question again was, how far did we row from this point S to this point T? You had to use the big triangle, find out that whole distance, which was X. And we had to use the small triangle and find out this distance Y. And then D, therefore, was this distance in between, okay? So X minus Y gave us D. That's the end of this video.